Hello and welcome to the Motion Coded Light project. My name is Neil and I'm the creator, head editor, and lead contributor of the Forcetronics blog. So what is a motion coded light? Well, I was looking for a fun way to turn on the light at my dinner table. I thought, well, I could have some type of motion like a hand wave to turn it on, but it couldn't just be a simple hand wave or else I would accidentally trip it and turn it on inadvertently. So I wanted to do some type of motion code, almost like a secret handshake. Visuals always speak louder than words, so here I have a quick video to kind of show what I mean by a motion coded light before I get into the project. So this is just my prototype setup, but let me show it to you real quick. So basically a quick hand wave is, and then when the hand coming back for a second was what I used to turn on and turn off the light. So that's what I mean by a motion coded light. Now, of course, that's the code I used in this project, but of course you could do it any way you want. Okay, here's the bill of materials for this project. I used an Arduino Uno, and I think everybody listening probably knows where to find those. If not, just search online. You'll find plenty of people selling those. And then I needed an automated switch or relay to control the AC light, and also needed a fairly high powered relay because I was going to have AC power that's going to the light. So on SparkFun, I found a big relay they have there for a pretty low cost. And then also too, to drive the relay, you can't just use the digital pin from the Arduino because this is going to take more power than that pin has. Besides the relay, you also need a little control circuit to power the relay. You know, you could buy the relay, you could build the control circuit, but what I'm getting to is I just decided to buy SparkFun's kit, which they call the Beefcake Relay Control Kit. And then to sense the motion, I have an infrared switch sensor. If something's in front of the sensor out to a certain range, it'll read one value. If there's nothing in front of the sensor, it'll read another. Then also I added a manual switch in case for some reason this were to stop working, my motion coded light, I have a manual switch to work around so I can still turn on and off my light. Of course, you need a light to control. In my case, I had an Edison light bulb that was over my dinner table. And then also you need some general wiring. So that's the bill of material for the motion coded light. Here's my schematic. So what's nice about this is all the electronic parts run off of 5 volts. So what I did was I had a old internet router that was no longer working, so I stole the DC power supply, so plugged that in. I plugged right into the Arduino Uno's power input. That put out 9 volts. The Arduino's regulator bumps that down to 5 volts, and that 5 volts powers my Arduino board. It powers the infrared sensor and also powers the Beefcake relay. If we start from left to right, you can see the infrared sensor switch on the on the left. That is pretty simple. It has 3 wires, a power and a ground, and then the yellow wire is the output, and it basically has an analog output. So I used an analog pin on the Arduino to read the output of the infrared sensor switch. I used pin 5. And then the Beefcake Relay Control Kit. 5 volts to power everything, you have ground, and then you have a digital control. That digital control is what's going to turn the relay on and off. So the relay is normally open. So if it doesn't have power, it's going to be open. I have it tied to digital pin 9 on the Arduino, and if 9 goes high, it turns the relay on or closes the relay. And when digital pin 9 is low, the relay will be open. And you can also see I have my manual switch in parallel with the relay. I have the AC wiring, so one of the wires that runs to my light bulb, I have it in series with the relay. So if the relay is open, the circuit to the light bulb is not closed. If the relay is closed, that closes the circuit and allows the light bulb to turn on. You can see my warning on the bottom. Of course, when you're working with the light, you don't want it plugged in. If it's a hardwired light, you want the breaker to be off. I will mention my manual switch. I got it at Radio Shack. They have a lot of switches there. Most of them are only rated for DC. This one was actually rated for AC as well. Okay, let's look at the code for the Arduino. Okay, here we have the Arduino sketch for the project, Motion Coded Light. At the top, I have my global variable tog, which controls the state of the light, or I should say the state of the relay. I have another constant value, val, which basically is used to tell if the sensor value is lower, an object is in front of the sensor. If the sensor value is higher than val, there's nothing in front of the sensor. In my setup function, I turn my digital pin, which is going to control turning the relay on and off. I set that to output. So the main loop is going to start with an if statement, and basically it's going to look for an object or something to be in front of the sensor. Once we detect something in front of the sensor, so if you remember the motion code that I had for the light, a hand waves quickly in front of the sensor, it quickly moves away, then it quickly returns and it stays there for a second. If we think about that, we want to look for something in front of the sensor. Once we see it there, we go into a for loop. And you can see the for loop has a delay of 30 milliseconds. What's going to happen is that for loop's going to run, and it runs for a total of 420 milliseconds. Basically, within that time period, we have to see that object leave the front of the sensor, or the code is not correct and we break out of the loop and we have to start all over again. If we detect the object moved out of the way in 420 milliseconds or less, we then start another loop, a mirror loop, to look for the object to come back within 420 milliseconds. So the hand waves in front, it moved away, we're looking for it to come back. Once it comes back, we then create a variable called activate. We start activate at high, and basically if activate stays at high, we use it to toggle the relay. So then we get to the third loop, and this is the one where it's looking for an object or your hand to be in front of the sensor for at least a second. There's a delay of 10 milliseconds. We run the loop 100 times, that's 1 second. If at any time the sensor detects a high value, meaning that the object left, we turn activate the low, we break out of the loop, and the relay does not change state. If the loop finishes and the object's still in front of it, activate remains high, and we enter the last if statement. If activate equals high, we then call a function that'll change toggle. We then do a digital write at whatever value toggle is, low or high, to change the state of the relay. So to turn off or turn on the light, depending on what it was before. Also in that if statement, we want to delay. You can see we have a delay statement. So we delay for 1.5 seconds. And the whole point of that is after you turn on the light, just in case you don't get out of the way, or we don't want the light to be accidentally turned on or off again quickly. So you can see I have a couple breaks there in case the other loops aren't satisfied. It breaks us out of them, and you have to start the process over. And then at the end of the main loop, I just have a delay for 100 milliseconds. So if you mess up something, it gives you some time to reset. And the only function I have in this sketch is the toggle switch function. And all this does is read the state of tog, the variable, and changes it. If it was at high, it changes it to low. And if it was at low, it changes it to high. That is the code for this project. Okay, mounting the parts. So we have all the electronics. I want to put them on my dinner table, but I don't want them to show. What I did was I took a drill bit, a paddle bit, and I think the paddle bit was, in fact, I know the paddle bit was 11/16, and that's inches. I drilled a hole. I was able to fit my sensor in there. And what's nice is I put the electronics on the bottom of the table, and I have the sensor on the side. So you really can't see anything. All you see is the sensor, which is pretty discrete on a black table. And you just have the power cord coming down. You can see in my electronics I put on the bottom. Now I just use some standoffs and some screws to put on the electronics. The Beefcake relay board is in red. Of course, the Arduino board is in blue. And then I just used some scrap wood, some wood glue, and some screws to put it on. And then I had a piece of plexiglass. So I cut a piece of plexiglass to fit over it. So that way my electronics is covered. Okay, now let me show you the finished product of the motion-coded light project. So there's me, there's the black table, and there's the light above it. There, so I turned it on, and then I was easily able to turn it off. So This is a nice project because it's, especially if you're a beginner or if you just want a cool way to turn on and off your light. You know, the pieces are pretty simple, the code is pretty simple, the project itself is pretty inexpensive. Okay, so let me wrap up. If you're watching this on YouTube, you can find the text for the Arduino code and the project schematic picture on my blog along with this video, and you can see the web address for the Forcetronics blog, or you can just search on Forcetronics. The blog will be top of the list. I also have you could check out my previous project, which is actually a little more complex, a little longer. It's building a wireless temperature sensor network. So that's there on the blog. If you have any questions from this project, you can email me at forcetronics@gmail.com. And if you enjoyed this project at all or you got something out of it, please go to my blog and click on one of the ads. That'll give me about 60 cents to apply to the parts for my next project. Thanks for watching.